All right, 8th graders, lesson 62, graphing on a number line, especially inequalities. And your book shows here Tom could be thinking of a number between 1 and 10. Normally when we play that type of number game, we think someone's thinking about a 2 or a 4 or 7. But they could say 2.5. They could say the square root of 8. They could do a lot of numbers. So when we're graphing this, we could say, well, it's got to be greater than 1, but it's got to be less than 10, any numbers in between. And if we were to then graph that on a number line, we would leave the ends open because they do not include 1 or 10. It's got to be between 1 and 10. Like 2, 3, 4, 5, 6, 7, 8, 9. Any of the numbers in between. So we would have to then color this line, so using another color here might be a little bit better. Does not include 1 or 10. It's anything in between. Okay. Whereas if I wanted to include 10, it could be greater than or equal to 10. If I added that symbol there, then over here by 10 I would have to color in the circle so that it was included. So just remember that. If it's colored in, it's included. And if it's not colored in, it's excluded. It's left out. Okay. Alright, in example 1, Christina is thinking of a number. If she doubles the number, the product is greater than 4. Write an inequality for this description. A graph on a number line, all the possible choices. So she's thinking of a number, x. She could double the number. The product is greater, so the answer of those two is greater than 4. So I've written the inequality. Now I need to graph on a number line all the possible choices for Christina's number. So x could equal, well, it's got to be greater than 4, so x could not equal 2 because 2 times 2 is 4. And then this would not be true. 4 was not greater than 4. So x is going to have to be greater than 2. So if we were to put this then on a number line, 2, 3, 4, 1, 0. If I were to put this on a number line, it could be any number larger than 2. But it could not include 2 because we found that 2 times 2 is 4. So I'm going to put an open circle there, therefore showing it cannot include 2, but it could be 2.2 or something, 2.5. That would be good. So that's why we include the numbers between 2 and 3 there. Alright, example 2. We've got 3x plus 1 is greater than or equal to 7. So we need to solve this problem. And so I'm going to subtract 1 from each side. So I'll have 3x is greater than or equal to 6. And now I can divide each side by 3. So I'll have x is greater than or equal to 2. And now I can, or is less than or equal to 2. So here's my number line. 2, 3, 4, 5, 1, and 0. Grab another color here. So it could be equal to 2. So put a dot there, or less than. So I can put that number in there on that number line. Now if I wanted to try it, I could say, well, what about 1? Let's put 1 in up here. So 3x plus 1 is got to be less than 7. 3 times 1 is 3, plus 1 more is 4. 4 is less than 7. So that would be true. Okay. So that answers example 2. Example 3, Vincent goes to the store with $20 to buy a notebook for $4. He notices that packages of notebook paper are on sale for $22. Write and solve an inequality to show the number of packages of notebook paper he could buy If he also buys the notebook, ignoring sales tax, then graph the solution. All right, so he has to buy the notebook. That's $4. And then he could also buy some notebook paper, some reams of paper, and those are on sale for $2 a piece. And I don't know how many of those he's going to buy. I know he's only going to buy one of these, so I can put in the 4 and not have to have a letter after it. However, he's going to buy reams of paper. It did not tell me how many. It just told me that they're $2 each. And he's going to buy some. But the total of these two numbers has to be less than or equal to 20, because that's how much he has. So less than or equal to $20. Now, if I were to graph this, I would do that by solving here. So I would subtract 4 from each side. So I'd have 2x has got to be less than or equal to 16. Now I divide both sides by 2. And I get x is less than or equal to 8. So the number of reams I can purchase would be 8. Now he can't buy 7.5, and he can't buy 6.5. Okay, or 5. He's got to buy a whole ream. So if each ream is $2, and we get our number line here, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And on our number line here, we would have to put dots. You could buy 0 reams if you wanted. You could buy 1 ream, 2. So we filled in dots at each of the places up to 8. Not more than that, because x has to be less than or equal to 8. And it can't be a 4.5, because we can't purchase a half of a ream or anything like that. So it's got to be the whole numbers. So he could purchase 0 reams, or he could purchase 8 reams, or he could purchase 1, 2, 3, 4, 5, 6, or 7 reams. Therefore, we've shown that here with our graph. Example 4, we've got 3 is less than or equal to x minus 2. Alright, so the first thing I'm going to do is add 2 to each side. So I'll have 5 is less than or equal to x. Now, it says that I need to graph this equation. 4, 5, 6, 7, and 8. And it could be equal to 5, so I put a solid dot there and 5. X could be greater than 5, so we would say that. We could test a few numbers in there if we wanted and go back and find out, see if exactly if that's true, but that would be true for us. Alright, that is lesson 62. You can get started, 8th graders.